In example 8, we again want to find the inverse of this given function, which in this case is the function h. We'll rewrite this as y equals 5x plus 3 over x plus 4. And then what we'll do is again look at swapping our values for x and y. To rewrite this as x is equal to 5y plus 3 over y plus 4. We'll multiply both sides of our equation by y plus 4 to eliminate the rational terms, which will give us x times that quantity y plus 4 is equal to 5y plus 3. Distributing through will give us xy plus 4x is equal to 5y plus 3. Next, we'll group all of our y terms on one side, which will give us xy minus 5y, and move all of our non-y terms to the other side, which will give us 3 minus 4x. On the left-hand side, we can factor out that y that's common, leaving us with y times the quantity x minus 5. And then divide both sides by x minus 5 to give us y is equal to 3 minus 4x over x minus 5. Or what we could say is that h inverse is equal to 3 minus 4x over x minus 5. Example 9 isn't too different from the previous problems that we've considered here, but we do have an additional statement. We're told that this given function k of x is 1 to 1 while x is strictly greater than 0. That domain restriction is required because what we have graphed below is the function k of x for all values of x, and we can see that it's easy to find a horizontal line that would cause this function to fail that horizontal line test. So this entire function isn't 1 to 1, but if we eliminate or restrict our domain so that we're only dealing with positive values of x, then what we have is a function that is now 1 to 1. So that domain restriction is specific in order to give us a 1 to 1 function. So we have y is equal to x squared minus 3 over 4x squared. We'll flip the positions of all of our x's and y's. And then multiply both sides by 4y squared to give us 4xy squared is equal to y squared minus 3. We can look then at grouping all of our y squared terms on the left-hand side. And then factoring out that y squared that's common to give us y squared times the quantity 4x minus 1 is equal to negative 3. Dividing both sides by 4x minus 1 will give us negative 3 over 4x minus 1. From here, what we can do is take the square root of both sides. When we do, we introduce that plus or minus notation. In this case, though, we know that in the original function, we had to have x greater than 0. If that's true, then for our inverse function, we flip x and y, so y has to be greater than 0. So we only consider the positive result. We only consider y is equal to plus the square root of negative 3 over 4x minus 1. Having that negative under the radical may be a little disconcerting, but keep in mind we could rewrite this function by applying that negative to the denominator instead of the numerator, and rewrite this as 3 over 1 minus 4x. In either case, we're not taking the square root of any negative numbers, or we're at least not including those as part of our domain. So what we end up with is k inverse equal to the square root of 3 over 1 minus 4x.